the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact. Welcome, Mark.
Thank you. Thank you, Professor Zibbs. And it is my pleasure to be here with all of you today. I really enjoy my opportunity to lecture the Stevens Institute of Technology students. Some of my other students from Cooper Union may be joining us. I see at least one of them. And the company we're with here, as you can see on the slide, is very impressive. Professor Zibbs has certainly accumulated a lot of respect in the industry. I see that Kate Aglitsky just signed in.
Yeah, I have a bunch of my students here. I want to say hi.
Okay.
Hi.
So with that, I'm going to get going. As far as today's lecture is concerned, you know, as you were already been told by Professor Zibbs, in the Sustainability Seminar Series, today's is special because we're going to attempt to address the common contaminants of concerns, but not just the contaminants, but the solutions. And I like to say we're going to put it in the palms of your hands. We try to simplify it in the way that it's manageable. In this introduction slide, you may see me operating an interesting device. This is actually a survey that I did in Oakland, California, for the town of Oakland. It's a very large site where we surveyed the site for environmental hazards. And we used, yes, you guessed it, it's a drone, several drones we used to survey this site. And the special glasses that I'm wearing in that picture allowed me not only see the drone up in the sky, but also see what the drone sees inside those glasses. So it's one of the ways to be efficient, ergonomically correct, but also be very much with the technology and illuminating the safety factors associated with doing surveys and in the sustainability direction. As Professor Zibbs had mentioned, I like to keep busy. The busy is what I like to do, and it shows not only with my acronyms after my name, which I'm proud of all the credentials that I have acquired, but you know, we're learning something new every day, and I hope to to learn something from all of you here today as well. There will be a Q&A at the end of my presentation, about 10 minutes before 6 p.m. The palms that I mentioned that we would like to put all the contaminants of concerns solutions in actually is an acronym. It's a mnemonic device to help to remember the common concerns, and these concerns are in the environmental health and safety field. They are today include PCBs, and P is the pandemic, A for asbestos and arsenic, lead, Legionella, mold, metals, heavy metals that is, and silica, safety and sustainability. What it all started, it started with a simple contaminants of PCBs that we would find still today in any kind of sealants. Anytime you have two different types of materials together, the building code will require to have a sealant. That sealant, if manufactured prior to 1978, will have most likely PCBs in it. Asbestos is another carcinogen that's been heavily used in insulation for thermal and chemical resistance qualities, as well as it's a miracle fiber that is fire retardant, and it's inexpensive in the days that it was used, and also provides a great reinforcement of any construction material that it's been used in. Over 3,000 different construction materials still today contain asbestos. As I said, a carcinogen. Lead, on the other hand, is present in paint. Lead is not a carcinogen, it's a poison, and it's a very serious concern for anybody who's exposed to it. Mold, this is an actual picture of a ceiling we discovered after Hurricane Sandy, where the water got into people's homes. Thousands and thousands of homes were affected. When the water rescinded, mold started growing. And silica, just like asbestos, it's a carcinogen. It's a dust that once it gets into your lungs could have severe implications and effects on anybody who's exposed. Here we see a picture of a construction worker cutting cinder block, and guess what? That dust, that plume, is what we are breathing, and it is a carcinogen. So it all started out as PCBs, asbestos, lead, mold, and silica, which spells the palms, but it expanded into several palms of other common contaminants of concern, and we're going to be addressing the different solutions associated with each of the acronyms. And again, we put it in the palms of your hands. Here's an example of a project that I was involved in. Here in New York City, we have 1,500 school buildings, and this was a retrofit project of lighting upgrades, of getting new and efficient lighting, getting the old light fixtures removed, and other requirements, local law requirements, local law 88 here in New York City. And in doing so, you look at these light fixtures that they've been there since 1950s, and guess what you're going to find in doing the replacement of these light fixtures. If you look inside the fixture, you can see on this insert you will find a ballast, and that blob, the dark blob, is actually PCB oil. There are oftentimes a PCB sticker that will indicate that it's a toxic environmental contaminant requiring special handling, and the kids in schools may have potentially been exposed to it because the ceiling fixtures are right above their heads and the oil would be coming out. If you look at the fixture closely, you will find these electrical wires that are insulated with this braided insulation, white braided insulation, and sure enough, that's the asbestos containing insulation. So altogether, we look at PCBs, polychlorinated biphenyls, man-made chemical manufactured by Monsanto Company under trade name Arachlor. There were 7 of them, man-made, not naturally occurring, as asbestos is, and asbestos-containing materials, lead in the paint of housing of the fixture or in the ceiling. Sometimes you see mold in the ceiling, the mercury vapor inside the fluorescent light tubes, silica, concrete ceiling. If you drill to it, that's the silica dust that we may be exposed to. So a lot of concerns here, a lot of contaminants we need to be aware of how to handle properly. Hence, putting it in the palms of your hand. There is no way you can do this project without really appreciating the fact you have this numerous contaminants in one place and you need to do them properly. So City of New York actually took note of this, and they created a master environmental hazard remediation, a technician voluntary registration program, where they say, we know in many projects, oftentimes we have to deal with numerous contaminants. And these are the common contaminants. It's not a secret anymore. Everybody knows what they are. And it's the microbial contamination, it's the asbestos, and it's the lead, and it's the hazardous waste, the PCBs, bloodborne pathogens. ICRA, the number 10, actually stands for the Infection Control Risk Assessment. And OSHA, as you see in number 7, is definitely something we need to be aware of. You probably hear that in your classes often, and other contaminants as a result of a fire or water damage situation. So all of this together is a lot of training, 174 hours total to earn your Master Environmental Hazard Remediation registration. Well, you thought that was a lot, but if you look at this slide and you're trying to find solutions, and I promise to put that in the palms of your hands, you would say to me, Mark, there's a lot of different regulations, guidelines, standards depicted here. You may recognize your institution's logo at the bottom left as I'm sitting. And but these organizations, these standard developing organizations, these regulatory agencies, these government entities and non-government entities are very important in the work that we do. What I don't have here, but I do proudly wear this pin. I don't know if you can see the pin on my jacket. I don't know if anybody knows what it stands for. It's not one of the entities mentioned on this slide. It is actually United Nations Sustainability Initiative pin that I was recently presented with, and I am very proud of, wearing it. Yeah, so United Nations, has an initiative and priorities of sustainability around the world. So how do we look at this slide with all the different references, and how do we know what is important to us? How do I make sure that in complying with one standard, perhaps, I'm not violating a regulation? Well, that's where training education comes in. The one thing that I would like to emphasize is that OSHA and NIOSH, National Institute for Occupational Safety and Health, have put their heads together and in recent years created this wonderful hierarchy of controls pictogram. And it's really, really important to us when we deal with any hazards. Just as the top of the slide says, solutions in the palms of your hands. Well, this is how you need to approach any contaminant. And this is how we need to think of any solutions and how to approach it properly. It's an upside down pyramid. And many of you engineers and architects would tell me, Mark, if it's an upside down pyramid, the base is unstable. And that is exactly the point that NIOSH and OSHA were trying to emphasize here. If you only rely on PPE, and you all know PPE, in the age of COVID, we all know PPE stands for personal protective equipment. What NIOSH and OSHA are emphasizing, if you only relying on PPE, it's unstable, it's not reliable. And so we're gonna go up the hierarchy of controls, and the very top, and that's the beginning of every control to address it properly, is to eliminate the hazard. Try to substitute the hazard. Institute engineering controls, administrative controls, and only when nothing else is feasible, possible, only then we rely on PPE. So this is an important pictogram. I think it provides a very important idea that the world cannot be safe just based on one thing. It's always a combination of several things, and we should pay attention and prioritize things that are definitely will provide us with safety, as opposed to PPE that may be jeopardized or subject to repair, and then we are exposed. And we always test our assumptions. Just as we think we know everything, something new comes up. And job safety analysis, job hazard analysis are necessary on a daily basis, because on the construction site especially, or manufacturing site, or any other occupational setting, things change. So don't assume that what you learned yesterday may save you today. We're finding out new contaminants. And this actually is, again, United Nations, what we refer to as the globally harmonized system. It was initially developed by United Nations, then adopted by United States Occupational Safety and Health Administration, OSHA, and it is now the law in this country to follow it. There are only 9 of these pictograms depicting hazards, and guess what? We can communicate with just 9 of them with the rest of the world. Here's an example of what OSHA put together as a way to protect the workers from respirable crystalline silica, or RCS. And this is the standard. It's right there on the slide, 29 CFR 1926. Part 1153, and it did its homework. OSHA presented Table 1, which specifies exposure control methods when working with materials containing crystalline silica. They also offer you a performance option where each employer must assess each employee's exposure by air monitoring on 8-hour time-weighted average. That's the average day that OSHA established for occupational setting, 8 hours a day. And if the worker needs to work more, OSHA says do not penalize the worker by overexposing them. That's why it's always 8-hour time-weighted average. The objective data means information that we get from other sources, not from directly monitoring your employee, but looking at others in the industry to see if there's any industry-wide information available. And also, what is possible is to look at the historical data of your own employees, the monitoring that was done in the past. The data must reflect worker exposures on each shift, each classification, because the exposures may be different for like the saw cutting person versus somebody who sweeps the floor. And no matter what we do, we got to look towards the future. You know, I'm glad to be part of the sustainability series because we really here, you know, for that continuous improvement. It doesn't happen on its own. We need to put some major effort into it. However, still today, many continue to rely on lagging matrix. Oh, you know, we had some incidents in the past, and that's all we're going to judge you on your past, which is a failure-focused measure. Lagging indicators measure the occurrence and frequency of events that occurred in the past, such as the number or rate of injuries, illnesses, and fatalities. We are getting away from it. I was in a meeting this morning with a major construction, worldwide construction company, and it's all about the leading indicators that offer a more useful gauge of activities by providing early warning signs of potential failure and thus enabling organizations to identify and correct deficiencies before they mature into accidents and injuries. Leading indicators are proactive, preventive, and predictive measures that provide information about the effective performance of your safety and health activities and measure events leading up to injuries, illnesses, and other incidents and reveal potential problems of your safety and health program. So we're going to focus on the safety and health program for the rest of my presentation because I believe you cannot talk sustainability without keeping everybody safe and healthy. So while lagging indicators can alert you of a failure in the area of your safety and health program or to the existence of a hazard, as we mentioned before, you know, the pumps, you know, PCB, asbestos, lead, mold, and silica, the leading indicators allow you to take preventive actions to address that failure or hazard before it turns into an accident. Good program uses leading indicators to drive change and lagging indicators to measure effectiveness. So you may ask, you know, Mark, what is a good example of leading indicator? Well, you taking this training today is one of it, okay? The amount of time it takes to respond to a safety hazard report is another one. And this example talks about the decrease in the response time may demonstrate an increased awareness in safety and managers' commitment to workplace safety. Conversely, though, an increase in response, meaning nobody cares, could signal a lack of management concern, which could mean that hazards are likely to remain uncontrolled and incidents are more likely to occur. And of course, when this happens, the workers start caring and paying attention and may not report hazards at all. So the continuous improvement efforts, each company may measure it differently, and each company will have their own elements for safety and health programs. Employers can also improve their overall organizational performance. In addition to social benefits, employers can use leading indicators to find and fix hazards and can realize direct savings to the bottom line. We need to not forget, it's not just a good idea. It saves people lives, and actually by doing that, by saving their lives and keeping them healthy, it contributes directly to the bottom line of everyone, the society as a whole. For example, by fixing hazards that led to roadblocks in production, employers may be able to complete daily tasks more efficiently and reduce production costs related to those activities. When we talk about health and safety, it's something that is hard to put in the palms of your hands. However, when you start talking about productivity to companies, they pay attention. So good leading indicators are based on the SMART principles. And I'm not just talking about you being smart. SMART, of course, stands for specific, measurable, accountable, reasonable, and timely. SMART, right? So some of you may have heard this principle back in high school. It hasn't changed. It still is applicable. And this is how the good leading indicators are based on. This slide is a reminder that not just OSHA is thinking this way, but the whole world, because the ISO, the International Standards Organization, has published a health and safety standard referred to as 45001. I'm also proud to be the US representative to this technical advisory group that we worked on in publishing the standard. It's a very comprehensive publication. 75 countries were involved, so you can only imagine trying to find consensus, not just with your peers and colleagues here, but in 75 other countries. Language barriers and cultural differences, all of that together to find consensus is a very impressive achievement. So the steps that we all agreed upon, such as PDCA, which is Plan, Do, Check, Act, is something that you will see in the OSHA guidelines, and ISO relies on that heavily. The leading indicators that support management leadership is critical because management needs to be on board to implement it. And how do you measure that? It's all about measuring. And you've heard some of your professors, even here on the call, saying, how can you improve something if you don't measure it first? So here's a list of items that one can measure when it comes to management leadership. But look at the other list of factors you can measure with worker participation. All of these could be assigned a grade. And this is very, very important. Assigning a grade, just like, grading your papers and grading your participation at the university is important. We also going to grade things pertaining to hazard identification and assessment. And that would include the frequency with which preventive equipment maintenance tasks are completed, number of hours passed after an incident, number of hours passed after an incident, before the investigation, percentage of incident investigation that include root cause investigation, percentage of daily, weekly, monthly inspections, percentage of inspections that include a follow-up, and how the hazard's been controlled. I was trying to refrain from some drama that has occurred in New York. This past Friday, there was a fatality in one of the biggest construction sites in New York City on Park Avenue. You might have heard on TV, but you know, accidents do happen, so we have to take this very seriously. Hazard prevention and control, leading indicators that support that. Here's a great list here, and you know, we can come up maybe even with more things that are here on the slide. But let's talk about education and training. Number of trainings, percentage of workers receiving the trainings, percentage of incident investigations, percentage of improvement of post-training assessments, things like that really do count. And of course, the key is communication and coordination, the frequency of discussions, and the frequency of the employers visiting the sites, talking to the workers, whether they're their employees or contract employees, number of hazards reported again, and number of audits conducted. OSHA has come up with this wonderful illustration of how this all ties in together in a safety and health program. And if you look at it, I call it, you know, the pizza pie, because it's kind of the pizza slices, but you know, the whole pie is the key to success. So let's look at each slice separately. The first one is management leadership, and this is the one that creates a culture of safety, facilitates trust, and reinforces the core elements. The next slide would be worker participation. As we already addressed it, it results in better design, implementation, and evaluation. The next slide is your hazard identification and assessment. And again, it identifies and documents all known and suspected hazards. Next slide is the hazard prevention and control, which prevents injuries using hierarchy of controls. Remember that upside down pyramid. It's the engineering, work practices, administrative, and the last control is the PPE, personal protective equipment. Training and education ensures all workers understand safe work practices. They're familiar with the hazards. They know how to participate. They can recognize the PCBs. They can recognize the potential asbestos in the insulation. They can recognize mold or silica or heavy metals or Legionella bacteria or you know, the pandemic that we just went through. Those hazards first needs to be recognized and then of course addressed. Just when we think we got it all together, we need to evaluate our program, and there's always room for improvement. Every day we get smarter. Every day we want to be implementing new technology, and I'm going to show that to you in a moment. So we're going to assess the program effectiveness and implement any modifications as needed. And I don't know if any of you saw this, we call it the Swiss cheese model. This was derived by Dr. James Reason I love his last name, Professor Reason, right? He introduced the Swiss cheese model back in 1990, but you might have seen this in New York Times, articles pertaining to pandemic. And what it really means is that we institute layers of protection, and we think the more layers we have, the better we are protected. And in this case, we're talking about pandemic. So we have masks, we have layers of, vaccines and government communications and testing and maybe isolation that we all experienced. And we think that we're covered, we're protected. So what Dr. Reason pointed out way before the pandemic, back in 1990, just about the time that I started my own company, actually, that most of the time inherent risks are never realized because the safeguards are in place to prevent them. Beautiful. The safeguards are represented in this model as multiple layers of Swiss cheese. And as we know, Swiss cheese has what? Has holes. So every process has holes. And under the right circumstances, this holes could line up and lead to a penetration, and hence the error of an accident. Every site, every job requires multiple layers of protection to keep the workplace safe. It's never one thing. When used together consistently, the holes or the weaknesses in any single layer of protection, and we need to use that to offset. And this is what we use for intervention. But we need to monitor each layer. We need to make sure that we don't subject ourselves to that penetration. There's a new technology out there. I was on a project this morning where I saw this in real time being implemented. All it is a way to quantify the safety leading indicators, and not only quantify, but grade it. Hence, safety leading indicator grade, or SLING for short. And this here is an example of one way of doing it. This is a centralized and real-time way of collecting data and displaying data for full transparency to everybody involved. And the thing that I like the most is that you can visually see where you are. You know, everybody says, "Oh, we're very safe. Don't you worry." Only for everybody to find out that they were not safe. Something happened. So this is a graphical visualization of SLING report that it tells you, you know, we're at 79% out of 100. You know, we think we're doing great, except we're experiencing a dip. Something's going on. Something was overlooked. You know, if you remember that Swiss cheese model, we have a penetration. We need to address it immediately, get it fixed, address it, inspect it, replace it, whatever it may be, get it back up to where we want to be. You know, 81%, is that acceptable? If my kids come home with 81%, you know, would they get dinner? I don't know. I don't know, it depends. I see Zib's laughing. So the report assigns, you know, we spoke about time weighted average. In this case, it's a weighted average. Every category has a weight, and that is established as company specific. And it could be HR management, it could be your safety routine, it could be issues with management, it could be your critical roles in attending training seminars or performing safety audits. You will have an algorithm that will calculate that and assign weight, and that's how you visually be able to see where you are, how you rating the safety at that particular moment. This is actually the company, Safeguard or Autos here in the United States. It quantifies safety from 0 to 100, customized and weighted categories. Each site and category gets a score. And now, if my kids tell me, hey, everybody got a high mark today, and we want to ask, maybe the test was too easy. Why did everybody get a high mark today? So then you would want to review the test and may want to make the testing harder, and then work on that continual improvement. So that's really no secret here. That's how life works, right? And this may predict an incident and save somebody's life. I was invited to the recent New York build at the Javits Convention Center in New York City. I was on the panel of experts from OSHA to attorneys to major construction firms and safety professionals and regulators from New York City DEP and Department of Buildings, from cranes and derricks, high risk activities. And we discussed all of these issues and how to use technology to find that truth, to find that score that will give us a guide of what to do next. So I'm just sharing the image from that recent conference here in New York City. Now, I do have a quiz that I normally ask my participants to to tackle, to see. It talks about risk. It talks about hazards. Talks about risk management. It's 10 questions.